In this video, we will be talking about the ideal gas law. But first, let's recall something that's been learned earlier in your studies. You have to define what solid, liquid, and gas is. So first, we have solid. There are two basic characteristics for every state of matter. For solid, we have a solid has a definite shape. Likewise, it has a definite volume. That's all that we have to know for solid. For liquid, we have no definite shape because liquid is shapeless, and it has a definite volume. It still has definite volume, just like solid. As for gas, this state of matter has no definite volume, has no definite shape and volume. Now, there are just a few things that we have to know in terms of liquid. We have to know the meaning of surface tension. Surface tension is defined as the uneven forces on liquid surface. Now, one rule of thumb in terms of surface tension is that the higher the pressure, the higher the surface tension. So surface tension and pressure are basically, they're both, if you define it in proportion, they're direct. So another definition that you have to know is that about viscosity. Viscosity is basically the liquid's resistance to flow. As you can see in the world today, we have some liquids that they seem to be solid, but still they're liquid. What makes them look like solid is viscosity, such as, for example, honey. Honey has high viscosity. It's still a liquid. So yes. Now let's move on to the real topic now. The ideal gas law. So we have to define first the variables of our formula. So basically, our formula for the ideal gas law is PV is equal to nRT. So let's enumerate our variables. Variables, units, its corresponding units, and its other units. So first, in line with our formula, we have P. P stands for pressure. The abbreviation of pressure is P. The unit of pressure, the main unit that we use in the computation, is atmosphere. And for the other units, 1 atmosphere is equivalent to 760 torr. Torr is another another system of measurement in the world of organic chemistry. 760 torr, which is also equivalent to 760 mmHg, which is also equivalent to 101,325 Pascal, or PA, if I'm not mistaken, and which is also equivalent to 101.325 kilopascal. You abbreviate kilopascal as K, capital KP and small letter A. I hope doesn't really become confusing. Everything that we have to do in order to memorize is that 760 torr, 760 mmHg, these two values have the same quantity, which is 760. And we just have to remember that PA is 101,325. Memorize it like a password. And as for KPA, kilopascal, it's not really necessary to remember it, but I suppose it's best to keep this in mind, especially in the exam. Kilopascal has a decimal in between the 3 units beside it. Pascal has the entire number by itself. So that's just a suggestion in terms of how you could memorize equivalent units, the units equivalent to 1 atmosphere. You can also improvise on your own technique. Moving on, we have our second variable, which is V. It stands for volume. Abbreviation is V. So for the unit of volume, the main unit is liter. Liter. And for other units, we have milliliter. For mole, that is our N. So PV is equal to nRT. So mole is the main unit of mole is N, or could also describe it as mol without the E at the end. And for the other units, we have to take note of this quantity. I'm sorry, I think we have to take note of it later. The other units of mole is millimole. Moving on, we have Raoult's constant. That's the R in between N and T. The main unit, it's difficult to type it. I'll just write it manually. LATM or latum over NK. Liter times atmosphere, all divided by mole times RK, which is Kelvin, the temperature. I'll discuss more about temperature later. And for we have to take note of this. This is the one that I've been saying a while ago. 0.0821 latum over NK. We'll just copy paste this. Alright, let's move on to the last variable of our formula, which is temperature. For temperature, our main unit is Kelvin. As you can see in Raoult's constant, the unit, we have K. Kelvin is the main unit of measurement for temperature. While usually, word problems involving the ideal gas law, they usually specify temperature in terms of either degrees Celsius or degrees, you know where this is going, Fahrenheit. There you go. And I want you to remember this. You have to convert if ever the problem asks you to solve for something, a missing variable, provided that you know the Raoult's constant, because literally from the word constant, this is already the value. In every problem, it's always 0.0821. So yeah, really have to memorize this part. It's really valuable. Now, in order to solve for temperature, basically to solve for Kelvin, provided that you are given a temperature in terms of degrees Celsius or Fahrenheit, these are the conversion formulas. So I'm afraid we lack space. Let's move to the next page. Alright. So in order to find Kelvin, provided that you have degrees Celsius, Kelvin is equivalent to degrees Celsius plus 273. For example, you have 32 degrees Celsius. You want to convert it to Kelvin. Therefore, you'll have to add 273 and your the quantity of your degrees Celsius, which is 32 degrees Celsius. So 273 plus 32, we get 305 Kelvin. Okay, so we have to take note of this. Alright, to Apart from finding Kelvin, you could also make use of these formulas to solve for Fahrenheit, provided that you have degrees Celsius. So 1.8 times degrees Celsius plus 32. This is the formula in order to find Fahrenheit. In order to find degrees Celsius, you have to subtract your Fahrenheit with 32. So degrees Fahrenheit minus 32 divided by 1.8. We'll use it as a fraction. 1.8 will be our denominator. So it's really up to you in terms of how you want to memorize this. But I suggest you find it the easiest way possible. Alright, let's move to the next part of the ideal gas law. One thing that you have to know is all about the standard temperature and pressure. So standard temperature and pressure, I mean P and T. So our standard temperature and pressure, as for temperature, in Kelvin, our standard is 273 Kelvin. In Celsius, we have 0 degrees Celsius. And in Fahrenheit, we have 32 degrees Fahrenheit. This is another valuable lesson to learn. So in case that the question in your exam asks something that you have to find at least just one out of all variables in the ideal gas law, whenever the question doesn't specify either a temperature or a pressure, you'll have to resort to the default. So standard temperature and pressure, you have to memorize this just in case. As for pressure, our default is 1 atmosphere. We have to take note of that every time. As we have known a while ago, 1 atmosphere is equivalent to 760 torr, which is equivalent to 760 mmHg. This is not N, this is mm. Alright? Which is equivalent to also 101,325 Pascal, which is also equivalent to 101.325 kilopascal. So yes, this isn't really necessary to remember right now, but for safekeeping, if you really want to memorize it, feel free to. Just have to note, the most important thing to know here is that the standard pressure is 1 atmosphere, and the standard temperature is 270 Kelvin, 0 degrees Celsius, and 32 degrees Fahrenheit. All of these values are equal to one another. If you want to really check it, you can make use of the formulas that I've specified above, so that if you really want to make sure, and that already includes practice upon applying the formulas that were specified in the conversion of temperature from Kelvin to degrees Celsius to degrees Fahrenheit, or vice versa. So one of the last parts that we have to know before we venture to before you get ready in answering word problems involving the ideal gas law, you have to know that absolute zero is equivalent to 0 Kelvin, which is equivalent to negative 273 degrees Celsius, which is also equivalent to negative 459 degrees Fahrenheit. In the calculator or in the internet, if you search the temperature for absolute zero for Fahrenheit, it's not exactly negative 459. But for the sake of eradicating the decimal and just showing up the whole number, this is what we get, provided that we also apply rounding off. Alright, that's everything for this video. Thank you for watching.